Hello all, welcome to Code Hub. Today let us solve the LeetCode's daily challenge. The question is find and replace pattern. Given a list of string words and string pattern, return a list of words of I that match pattern and you may return the answer in any order. A word matches the pattern if there exists a permutation of letters P so that after replacing every letter in X in the pattern P of X, we get the desired word. Recall that a permutation of letters is a bijection from letters to letters. Every letter maps to another letter and no two letters map to the same letter. So this is the question and this is the problem. Let us take some examples and see. Let us take this example 1 itself, and here is the input words and the pattern, and we have to find what are the words which are in this words list that are having the same pattern ABB. If those words are found, we have to return those words. So let us see, let us take ABC. First the words ABC. Let us take the ABC word and ABB. ABB is a pattern. If A is mapped to A, then we can put this A as A itself. If B is mapped to B, we can put B, but we cannot say that C is mapped to B because B is already mapped with B. So C should be mapped with some other letters. So this ABC cannot form this pattern. So this is how ABC is not in our answers list. Let us take MEE. MEE, whether it is mapping with ABB. If we consider that M is mapped with A, then we can try to replace words. Those words. M is mapped to A, and consider M is mapped to A and E is mapped to B. So what we change these M and E with those mapped letters A and B. Let us see what is happening. M is A, so A. E is B, and again E occurs, so it is changed to B. So you can see, we can see that ABB and the pattern is also ABB. So it is a word which is our required answer. So this MEE is one word which is having a pattern ABB. So let us take AQQ as well. AQQ, and whether it is mapping with ABB. Consider A is mapped with A and Q is mapped with B. So and B can you consider we are having a letter B also. B should be mapped with some other letter. It should not be mapped with A or B again. So this is how it they are saying that it has a bijection. So let us transform this AQQ with this mapped letters. So A is mapped with A, so A stays the same, remains the same, and Q is mapped with B, so it becomes B, and another Q, so it is ABB. So we can see that ABB is equals to ABB. So what we have to do is we have to say that this A is mapped with this A, and and similarly this A is mapped with this A only. For these two words, this M is mapped with this A, and this string A should be mapped with this M only. It should not be mapped with any of the letters. So we have to maintain a one-one mapping, one-to-one mapping, so that we can say whether that string is mapping or whether that word is mapping or not. So let us think of some data structure that is having a having a map. So we can take map data structure itself. Map data structure, we can traverse the string. Let us take this example MEE, and the pattern is ABB. We have to make this MEE to map with this ABB. So while passing this MEE string, we can check whether we can put on a map that M is mapped to A, and next letter is E, so E is mapped with B. This is the second letter, so it should be mapped with B, and again comes an E. So this, you can see that E already occurs in B. Already there is a letter E in our map, so we should check whether that E whether the letter in the map is equal to this letter. Consider we are having ABC. Consider we are having ABC. We have to make that MEE to map with this ABC pattern. You can see that E is mapped with B, and we are having another letter, the third letter, which is E, which is already present in our map. So we have to check the mapped letter is equal to the same letter, or else there is a conflict. So we cannot say that this is present, this follows a pattern. So similar way, I hope you are I'm making sense. So E is already present in map, so E is mapped letter, which is B is equal to B, then we can proceed further, or else we should not proceed further. That's what I'm meaning here. So we can take some other example so that it will be more clear. A B C D D E F H. So this should map with some pattern J K L E I. So let us make this word to be mapped with this word pattern. So A is mapped with J. Okay, fine. It is reasonable. Next, we can try to map this B. B is mapped with K. Okay, fine. Since B is not in map, we are mapping this B to K. Then C. C is mapped with L. Okay, fine. C is mapped with L only. Then comes D. D is mapped with E. Okay, fine. D is not in the map. D is mapped with E. Next, again there is a D which is already in map. So which is already in map. So we should check whether the character mapped to D is this same letter E, or else there is a conflict. So that's what I'm making you clear that but if we maintain only one map, it is not possible to maintain the one mapping. So we will be maintaining two maps for both these characters in this word as well as in this words. What we are doing here, we are mapping this A with J, B with K. Similarly, we will be mapping this J with A, K with B, so that we can maintain that one-to-one mapping. And if there is a conflict occurs, then we will say it is false. So that we will not add that word to our resultant string. So let us code it so that it will be more clear. We will be having a vector of strings. I will say it as resultant, and finally I am going to return my res. So we will be traversing for each word. For auto word in my words, we will have a function check valid. Let us say this function to be check valid. If this word is matching with this pattern, then we will return true. If this returns true, then we will add that word to our resultant container. So hope you understand what I'm doing here, this for loop. Now let us define the function private bool check valid string word and string pattern. So we have to maintain two maps so that we will check for its one-to-one mapping. Unordered map char of char mp1 and mp2. So let us traverse the whole string. For each word, the word of i's length will be equal to this pattern's length. Okay, fine. So let us go and now traverse the whole string. For int I equals to 0, I less than word dot size I plus plus. if mp dot find of mp1 dot in first map, we are going to map mp1 is going to map word to pattern, and mp2 is going to map from pattern to word. If mp1 dot find of word of I, if this character is already present in my map mp1 dot n, if this character word of I is already present in my map, then it should be mp1 of word of I should be equal to this pattern of I. If mp1 of word of I is not equal to m pattern of I, then I should return false. Correct? Yes. Similar way, I should check for my pattern map 2. If mp2 dot find of pattern of I is already present in my mp2 dot n, is already present in my map 2, then that character mp2 of pattern of I should be equal to my word of I. So if it is not equal to my word of I, then I will just return false. If both these cases are failing, then we can map this word mp1 of word of I is equal to my pattern of I. Similarly, mp2 of pattern of I is equal to my word of I. So this is where we are mapping these two words. This maintains the one-to-one mapping. And finally, if all the characters are mapping exactly to the pattern itself, then we will just return true. Hope you understand. Let us run the code and see whether it is getting accepted or not. It gets accepted. We can use the example test cases. It got accepted. Let us submit our code. Here the time complexity will be order of n. That the n is the represents this length of this words list, and into m. The m represents the traversing this time complexity for traversing this words. So and the space complexity will be order of 2 into n, 2 into m, where that shows the space complexity is because of this map, using maps. So this is how the today's problem is looking like, and let us see in tomorrow's LeetCode daily challenge. Until then, bye. Hope you understand this solution.